No one will choose to use their phone, so we should be good. Okay, solving log equations. It says to simplify using the properties. The properties are what we just went over on page number 11. After you simplify using the properties, you need to isolate the log, which means make the log the only thing on one side of your paper, or one side of your equation. After you do that, you need to write it as an exponential, like we did when we were doing those magic square things, and then solve for x. So number one should be pretty easy. Do we need to simplify? Is there a log plus a log, or a log minus a log, or any exponents or anything? No. So the next step, isolate the log expression. Is there anything on this side of the equation besides the log? The 2x is there, but it's part of the log. It's inside of the log. There's nothing out multiplied. There's nothing added or subtracted, so all we have over there is a log. In part 3, we need to write it as an exponential, which means I need to change this into its exponential version. Now, what's the base of that problem in number 1? The base is 10. Y'all remember that from yesterday? Yeah. The understood base for a common log is 10. They don't write it, but they expect you to know it's there. So we've got 10 raised to what power? Negative 1 is the exponent, is equal to what? 2x. 10 raised to the negative first power is equal to 2x. Go ahead and write this down with us.
The understood of a log is 10?
The understood base of a log, if it's not written there, is a 10.
Okay.
Okay, so I have 10 raised to the negative first power equals 2x. What's 10 raised to the negative first power? 1 over 10 or 0.1. You can write it either way. What's x going to be if 2x equals 0.1? What does your calculator say about that? All we have to do now is divide both sides by 2. What is 0.1 divided by 2? Write this down with us, please. What's 0.1 divided by 2? Your calculator can tell you that? 0.05 or 1 over 20. So you can write it either way. X equals 0.05, or if you like fractions better, x equals 1 over 20. Both of those are correct. So I'm going to put a box around it and move on. All right, in number 2, do I have a bunch of logs in here? Is there one log or lots of logs in number 2? One log, only one log, so I don't need to use any properties. Is there anything on this side of the equation besides the one log? Anything added to or subtracted from or multiplied by? I got a plus 4. How do I ditch the plus 4? Minus 4 on both sides. All right, so some of y'all don't need to write that minus 4 because you know how to do it in your head. But we get a log of x equals 4. All right, so now the log is isolated. Next thing we need to do is rewrite this as an exponential. What's the understood base here? Still a 10. That hasn't changed from last time. So we have a 10 as the base. So what would be the exponential equation I could write? 10 to the 4th equals x. So now I just need to figure out what 10 to the 4th is, and I'm done. What does 10 to the 4th equal? 10,000.
Well, we put 4 zeros because it's 10.
Yeah, good. Look who still remembers that. Good. You go. All right, 4 zeros, 10,000, x equals 10,000. And we're done. In the green, it's 10 to the 4th power because our base was 10 and our exponent was 4, because logs are always equal to the exponents. All right, in number 3, how many logs do you see?
I see 1.
I see 1 log, so we don't need any properties. Do you see the log has anything added, subtracted, multiplied, or divided? Multiplied. How can I undo multiplication?
Addition.
No,
right? Division. My bad. I was thinking, like, you know how you turn multiplication into addition? And then you turn,
oh, I see what you're saying. I see what you're saying. Yeah, with log properties, but we're not using those for this step. So we divide. What is 1.5 divided by 3? 0.5. Sorry, what'd you say?
No, it equals 1
Yeah.
over 1/2.
We get, no, that's 0.5. 1 and 1/2 divided by 3 is 0.5.
Equals 1/2.
Okay, I thought you said 1 and 1/2.
Oh, I probably did. I didn't even say that.
Okay, we're good then. All right, so log of x equals 0.5. Now we need to do our little loop around, change it into an exponential. What exponential equation could I write?
X to the 1/2 equals dog. No, 10 over 1/2 equals X.
10 to the 1/2 equals x, or 10 to the 0.5. Either way you want to write it, decimal or fraction, equals x. So now I need my calculator. What's 10 raised to the 0.5 power? Yeah, it ain't going to be pretty, is it? All right, 0.707-ish. Does that work for you guys? I don't know where I'll have room to write it. 0.707 and a little bit of extra change. You didn't get that? Did I do it wrong? You're right. Thank you, guys. I made my key wrong. 3.16. Sorry. Thanks for saving that. All right. So, the next row is going to be pretty similar to what we just did on the first row. Take a look at number 6 real quick. In number 6, how many logs do you see?
1, 2, 1.
I see 1 log there, so we don't need to use properties. Is there anything added, subtracted, multiplied, or divided? Okay. Yeah, look at those parentheses. The difference between number 2 and number 6 is that in number 6 it's in parentheses, so it's part of the logarithm. We can't add to get that out. In order to get rid of that 2, we've got to change this into an exponential. So what exponential could we write for this one? What would be the base of our exponential? The base is still 10. What's the exponent? Logs are equal to exponents, so 10 to the first power is equal to what? X minus 2, you got it. 10 to the first power equals x minus 2. Well, what is 10 to the first power? 10. So I have 10 equals x minus 2. And so what is x going to equal? X equals 12 when we add the 2. Good. So if it's in parentheses, we can't get rid of it until we change it to an exponential. What about in number 5, working backwards? Can I get rid of that minus 3 in number 5? Yeah, it's not in parentheses, so I can add the 3 to both sides. And that's going to give me log of 6x equals, not negative 7, negative 1, because negative 4 plus 3 is negative 1. Now, what's going to be my exponential equation if I loop around here? Stay with us. The base is going to be 10. Understood? 10 base on a common log. 10 raised to what power? Negative 1 is equal to what? 6x. So I need my calculator maybe, but we already did 10 raised to the negative 1 power in the first problem, right? That was 0.1 or 1 over 10 equals 6x. So 1 over 10 or 0.1 divided by 6 tells me that my x is going to be 1 over 60. Or you could write that as a decimal, but I think 1 over 60 is a little bit easier to write than the decimal that we'd come up with otherwise. Okay, so I'm going to skip a few and go to number 9. Look at number 9. What's the difference between number 9 and the ones we've been doing so far? I got 2 logs, so now we're practicing what we just went over on our homework. How do I take these 2 logs and make them into 1? Division. See that subtraction, that minus sign? Subtraction in logs is changed into division in 1 log. So I have log of x divided by 3 is equal to 2. So if I have more than 1 log, I have to use my properties to make it into just 1 log. And then I change it into an exponential. What's the base on this one? 10. 3 is what we divided by, but 10 is still the base. So I have 10 raised to what exponent? 2. 10 squared is equal to x over 3. What's 10 squared? Y'all know that one, right? 100. 10 squared is 100. So I get 100 is equal to x divided by 3. So what is, sorry, y'all can't really see that 3 down there. Times it by 3. Good job, Will. And I get x equals 300. Okay. Now, we've done, what, 6 equations. How can I check the answers to these equations to see if they're right or wrong? Plug it in. You got a calculator. You can stick it in there. You'd have log of 300 minus log of 3, and that should equal 2. You can do that right in your calculator. Okay, I'm going to go to the next set at the bottom. Down here, starting with number 10. How many logs do you see in number 10? I see 2 logs. How do I make that into 1 log? Why is this one not going to be division? Because when you see a plus sign, you're not going to divide, you're going to multiply. So I'm going to write this as 1 log, and I'm going to have 2x times x. Now, some of y'all know that that's equal to something else. 2x times x is the same thing as 2x squared. So I can write this as log of 2x squared equals 1. So now that I've used my properties, how do I rewrite this as an exponential? What's the base? 10 to the first equals 2x squared. I have 2 steps left. 10 to the first is just what? Okay. Well, I get x squared equals 5, right?
Yeah, no, because you got to do the radical thing. How did you get that?
Okay. Which part? The yellow part or the green part? Green part. So what I did was I said, okay, 10 to the first is just 10, right? And then I divided it by 2. Okay? So I have 5 equals x squared, and y'all said we need to take a square root. Okay, cool. Good. I'm hearing people say the plus or minus. I hope you remembered that on your quiz. Good. Plus or minus square root of 5. I can't factor tree that. But here's a sneaky trick. Here's a problem with these. I want you guys to try in your calculator real quick to do the log of negative square root of 5. In your calculator, we said that one of our answers should be negative square root of 5. Let's see what our calculator thinks of that. Log of negative square root of 5. My calculator says no. It says error. Here's something you need to hear. We cannot ever take a log of a negative number. You cannot ever take a log of a negative number. And negative square root of 5 is a negative number. So the negative square root of 5 is not going to work for this. Only the positive square root of 5 will work. You cannot ever take a square root of a negative number. A log of a negative number. So anytime you have a negative number, you've got to toss it out. When you substitute it back in, if it gives you log of something negative, you got to toss it out. That's easy to forget. So find some place in your margin, maybe down at the bottom. You cannot take a log of a negative number. take a log of a negative number. I can't fit the whole word, so I'm just going to write a pound sign. You cannot take a log of a negative number. Stay with this. Okay, in number 11, how many logs do you see there? I see 2 logs. The answer number 10 is just the positive version. We can't use the negative version because it makes us take the log of a negative number. All right, for number 11, you guys said we see 2 logs. Who knows how I can make those 2 logs into 1 log? Brianna, what you got?
Log of x. Ooh. Log of x times 4. No, it's 2. It's 2 log. I don't forget it.
Okay, what does that 2 do? This guy right here.
Becomes a base?
Not a base, it becomes exponent. Good job.
Oh, that's right.
So we have x squared there. And then since they're plus, we're going to times, right, Diego? So we're going to have 4x squared. Because the 2 becomes the exponent, and we multiply the x squared times the 4. 4x squared equals the 2 over there. Now write it as an exponential. The base is still 10. 10 squared equals 4x squared. What's 10 squared? 10 squared is a 100. So I have 100 is 4x squared. Good job, Will. I divide both sides by 4, and I get what number? 25 is equal to x squared. Then I square root it. Square root of 25 is 5. Okay? Now, technically, I'm supposed to put plus or minus, but why am I leaving off the minus? I can't take the log of a negative number. Brianna?
Just basically, before you do that, with your 100 and your 4x squared, you do take the square root, like 10, and then it gives you number 9.
If you took the square root before you divided, you'd have the square, or you'd have 10 equals 2x squared, right?
Yeah.
So,
You get your positive number. You won't have a negative number.
yeah. Right. Okay. Which of the last ones do you guys think is going to be the trickiest?
21.
20. 19.
All right, let's look at 19. In number 19, we've got something a little bit different. What's the understood base if you've got an ln, a natural log? E. So we've got an understood little teeny tiny e. I can't even write it, it's so tiny. It looks like a big fat dot. Okay. All right. Now if I change this into an exponential, my base is e. What's my exponent? 5. E to the 5th power is equal to all of this. E raised to the x plus 1. Now this one looks a little bit weird. But if we have e to the 5th power equals e to the x plus 1, what do you think x is going to have to be? 4.
Where did you get 4?
Where did I get 4? Well,
Plus 4 is 5.
I have a 5 here and an x plus 1 there. Those should be, hold on, those should be equal to each other, right? If I've got an e over here and an e over here, so 5 should equal x plus 1. And when I subtract 1 from both sides, x is going to equal 4. All right? Now, tonight for homework, you don't have to finish the notes, but I will put the rest of the notes on Blackboard for you to look at along with this video. Your homework is page 13. All right?
Are you still really kind of like making a lesson, like explaining those, or you just gonna have like
I'm not sure I'll have time to explain it all tonight, but I'll try.
Okay.